the rate of change in the number of bacteria in a culture is proportional to the number present. Okay, so the moment you read those words, you need to remember the following. We said a rate of change in the number of bacteria. It means that the rate of change, the number dn, the number change in terms of time at some proportion, kn. So that is what that says. The rate of change in the number of bacteria so the rate of change, that's the rate of change of this number n, so this number change in terms of time, so that the proportional to the number present. So that means that k times n is proportional. Okay. Now I know from this that the moment I see this, I remember the following. I remember then that my formula in terms of n will be n equals a, e, k, and now it's not x, it is t. So I know that because of that, this is going to happen. So I need to find, first of all, they say develop a model or equation for finding the number of bacteria at time t. So at time t, I need the information, so I have to find A and I have to find K. Now, I'm going to read further. They say that initially there were 500 present, and after 3 hours, it has grown to 2,000. So I've got 2 bits of information there. Now let's go and see how I can develop it. If they say initially, it means when time is 0. Okay, so when time is 0, when time is 0, A equals, or N equals 500. Therefore, A is our initial value, so A equals 500. So we can immediately use that. Our second piece of information says that when t equals 3, the number has grown to 2,000. So I'm going to apply that now in my equation. I'm going to say when n is 2,000, it equals A, which is the initial 500, so much so that e to the power k, which I don't know what k is, multiplied by 3. Now I only have one unknown value, and that is k. How do I find k? I first got to divide by 500 on both sides. Okay? If I divide by 500 on both sides, 2,000 divided by 500 is going to be, I'll just do it, 2,000 divided by 500 equals e to the power 3k. I'm going to take ln both sides, okay? Take ln both sides, I'm going to swap sides. So e to the power 3k equals, that is 4. Take ln both sides, so therefore 3k equals the ln of 4. And I'm just going to carry on here. Therefore k equals ln 4 divided by 3, which you just do in your calculator, and then k is a constant value, and that constant value is 0.46. Now some advisors don't just use 0.46 in your calculator. This answer, store it in your memory and use the full answer when you do the other questions. Okay, so I have now a new equation. This equation has now grown to, and this is going to be my first answer, the equation will be n, the number equals A, which is 500, e to the power k, which is 0.46, multiplied by the time. And now all I have to do is, after how long did the bacteria double? Okay, so if it starts off with 500, so let's go now to another color. Let's do this now in B. So this was A. All of this was A. I'm going to go now to question B. It says, after how long did the bacteria double? So when did it n equals If it doubles from 500, it means that n is 1000. And all I'm going to do is I'm going to substitute this in here. So I'm going to say it's 1000 equals 500 e to the power 0.46t. I'm going to divide both sides with 500. So e to the power 0.46t equals, divide by 500, divide by 500 equals 2. I'm going to take ln both sides, so 0.46t is going to be 0.46t equals ln 2, and t equals ln 2, divide by 0.46, and my answer equals 1.5. So after 1.5 hours, the number has doubled. Okay, the last question. Question number C. How many bacteria was present after 5 hours? So in T is 5. So N equals 500, my original, E 0.46 times 5. You're going to chuck that straight into your calculator. And your answer is 4987. 4987, and that is how many bacteria will be present.